As the exponential expression above illustrates, an exponent is shorthand notation for repeated multiplication. Try to simplify the following expressions by using repeated multiplication. 5k to the fourth power is equal to 5 times k times k times k times k. In 5k to the fourth, there are 4 factors of k. An exponent is used to show repeated multiplication. Try to quickly find the value for 3 to the second power and 2 to the fifth power. 3 to the second power is equal to 3 times 3, or 9. 2 to the fifth power is 2 times 2 times 2 times 2 times 2. 2 times 2 equals 4, times 2 equals 8, times 2 equals 16, times 2 equals 32. 2 to the fifth power is 32. The product rule for exponents states that the product of two exponentials with the same base can be simplified by adding their exponents. A to the m power times a to the n power is equal to a to the m plus n power. Consider 2 to the third power times 2 to the fourth power. When you multiply 3 factors of 2 by 4 factors of 2, you will have 3 plus 4, or 7 factors of 2. Let's quickly look at a couple of examples. X times x squared is equal to x to the third power. Add the exponents. 1 plus 2 equals 3. 3x to the sixth power times negative 5x to the third power. Multiply the coefficients 3 times negative 5 to get negative 15. Add the exponents, 6 plus 3 to get 9. 3x to the sixth power times negative 5x to the third power equals negative 15x to the ninth power. Negative 2x y to the second power times 3x to the second power y to the second power times negative 1x to the fifth power. Multiply the coefficients. Negative 2 times 3 times negative 1 equals 6. Multiply the x factors. X times x to the second power times x to the fifth power equals x to the eighth power. Multiply the y factors. Y to the second power times y to the second power equals y to the fourth power. The simplified product is 6x to the eighth power y to the fourth power. The quotient rule for exponents states that the quotient of two exponentials with the same base can be simplified by subtracting their exponents. A to the m power divided by a to the n power is equal to a to the m minus n power. Consider 6 to the fifth power divided by 6 to the second power. 6 to the fifth power can be written as 6 times 6 times 6 times 6 times 6. And 6 to the second, or 6 squared, is 6 times 6. The two factors of 6 in the denominator can cancel 2 of the 6's from the numerator, leaving 3 factors of 6. You can get the same result by subtracting exponents. 5 take away 2 is 3. So 6 to the fifth power over 6 squared reduces to 6 to the third power. Here are 2 quick examples. Simplify x to the 20th power over x to the fourth power. Subtract the exponents. 20 subtracting 4 equals 16. So x to the 20th power divided by x to the fourth power equals x to the 16th power. Simplify negative 24 a to the third power b to the fifth power c to the first over 6a to the second power and b to the second. Negative 24 divided by 6 is negative 4. Subtract exponents to simplify a to the third power over a to the second power and b to the fifth power divided by b to the second. The final simplified result is negative 4, a to the first power, b to the third power, and c to the first power. The power rule for exponents states that a to the m power raised to the n power is a to the m times n power. Multiply the exponents when a number raised to a power is raised to another power. In example 1, x squared is raised to the fourth power. This can be written as x squared times x squared times x squared times x squared. Using the product rule, we would get x to the power of 2 times 4, or x to the 8th power. Instead of writing this as repeated multiplication, we can just multiply the exponents. X squared raised to the 4th power is x to the 8th power. In example 2, 10 to the 4th power raised to the 3rd power can be simplified by multiplying exponents. The result is 10 is raised to the 4 times 3, or 10 to the 12th power. When a product is raised to a power, the power rule will apply to each factor. Example 3 helps to explain this. 3x raised to the 2nd power, y raised to the 4th power, and z is raised to the 3rd power. The parentheses can be removed, and each factor inside the parentheses gets raised to the 3rd power. This will give us 3 to the 3rd power times x squared to the 3rd power times y to the 4th to the 3rd power times z to the 3rd power. Simplified to get 3 to the 3rd power is 27, x squared to the 3rd power equals x to the 6th, y to the 4th raised to the 3rd power is y to the 12th. The final result is 27, x to the 6th, y to the 12th, z to the 3rd. You should look over the examples on the web page and then test your knowledge using Test Yourself.